domain of a function is the set of all possible input values. We'll talk about some other names for domain in just a minute. The range of a function is the set of all possible output values. So some other names that we could see besides domain and range. For domain, we could see input, x-coordinates, and also independent variable. For range, we have output, y-coordinates, and dependent variable. So the combination that we'll hear those is domain and range, input, output, x-coordinate, y-coordinate, independent, and dependent variable. So let's take a look at this. Here's some examples that we'll look at. So example number one, we have two graphs here. The first one on the left is just represented by coordinate points. So we want to find the domain and the range. So for the domain, remember that is all of our x values. The range is all of our y values. So let's go ahead and label these coordinate points. So we'll start at the bottom and work our way to the top. So negative 1, 2, 3, 4, negative 1, 2, 3, 4, 5, 6. So this is negative 4, negative 6. 1, 2, 3, 1, 2, 3, negative 3, negative 3, negative 2, 0, negative 1, 1, 2, 3, and 0, 1, 2, 3, 4, 5, 6. All right, so for our domain, we're going to list all of our x values in increasing order. Okay, so we're going to say negative 4, negative 3, negative 2, negative 1, and 0. For our range, we will write those also in increasing order. Okay, so for our range, we have negative 6, negative 3, 0, 3, and 6. So domain, those are our x values. Range, those are our y values. All right, so now let's look at the second graph here. It looks a little bit different because we have some lines connecting our points here. So remember, domain is the set of x values. Well, on a graph, x coordinates run left to right. So we can think about this part of our graph almost from our leftmost point to our rightmost point. So at the left, we have negative 1, 2, 3, 4, 5. Right, so that's negative 5. And over here, we have 1, 2, 3, 4, positive 5. Since at the end, these points are closed, we include those points. So for our domain, we will say x values between negative 5 and positive 5. And that's how we will write that, okay, as a compound inequality. So x is between negative 5 and positive 5. Now for our range, that would be our y values, and y values on a graph are up and down. So in this case, we've got our lowest point right here, which is negative 1, 2, 3. And our highest point, which is 1, 2, 3, 4, 5. Okay, so we have negative 3. We're going to use a y this time, and we go to positive 5. So that tells me our range values are between negative 3 and 5, and we include those numbers in our range. All right, our second example, we're going to talk a little bit about independent and dependent variables. So as we saw in our table at the beginning, independent is part of our domain. So independent is like the input, which is our x values. Dependent variables will be our output, which is like our y values. Okay, so we're presented with a scenario here. It says the function t equals 15m plus 70 represents the temperature T in degrees Fahrenheit of an oven after preheating for m minutes. So we want to identify the independent and dependent variables. So remember, independent would be like our x value, dependent would be our y value, independent input, dependent output. Okay, so our dependent variable is the one that's going to depend on the independent variable. So in this case, our dependent variable will be t, and our independent variable will be m. Okay, whatever your equation is solved for. So in this case, our equation was solved for t. That would be our dependent variable. Okay, m is being multiplied by 15. That is our independent variable. All right, so now it says a recipe calls for an oven temperature of 400 degrees Fahrenheit. Describe the domain and range of the function. Okay, well, for the range, all right, range will be like our y values or our dependent variable, and that's our variable t for temperature. Okay, we know the max temperature. The max temperature is 400. That's what we're trying to preheat it to. Okay, so we're going to we'll use t for temperature, and we need it to be, it's going to be less than or equal to 400, right? It's going to heat all the way up to 400, but not go any higher. So now where do we start? Well, that's our y-intercept of our equation over here, our initial value of 70 degrees. Okay, so before we turn the oven on, it's already 70 degrees. That's probably room temperature for most homes. So there's our range. All right, for our domain, we're going to have to calculate a little bit. All right, our domain. Okay, in this case, it's minutes. So we know we're going to start at 0, right? We haven't started the oven yet. So we're starting at 0, and we want to get it to 400. So I'm going to take 400, and I'm going to plug it in for t in my equation. So we're going to say 400 equals 15m plus 70. And we're just going to solve for m to see how long it's going to take for our oven to get to 400 degrees. So let's subtract 70. We get 330 is equal to 15m, and we divide both sides by 15. Okay, when we do this division here, we're going to get an answer of 22 minutes. Okay, so we have our domain and our range. This tells us that it's going to take 22 minutes to preheat the oven. So our domain would be from minute 0 all the way to minute 22. And our range is our temperature. So before we turn the oven on, it's room temperature, which 70 degrees makes sense. And then it's going to cover every temperature all the way up until 400 degrees. And that is how we work with domain and range.